Lesson 9.2, Gaussian Elimination. What you've already done in the previous lesson was actually Gaussian elimination, which is solving a system of linear equations by putting it into row echelon form using the elementary row operations. Well, that was expanded by Jordan, so we have Gauss-Jordan elimination, which is putting the system into reduced row echelon form. For a reduced row, if a row becomes all zeros with the final entry not zero, so it's 0, 0, 0 number, then there's no solution. If a row becomes all zeros, then there's infinitely many solutions, and you have to do the z equals a thing to write the parametric equations, the line of intersection, because in three variables, each graph a plane, and the intersection of planes is a line. So we're trying to describe the line that contains all the points of the intersection. Let's solve this system. Let's start by putting it into a matrix. 1x, 0y, negative 3z, negative 5. 3x, 1y, negative 2z, and negative 4. 2x, 2y, 1z, and negative 2. My top left entry is already a 1, so then let's make zeros below that 1. So let's make that 3 a 0. So I could do negative 3 times the top and add it to the second. The top row is staying the same. The bottom row is staying the same. The middle row becomes negative 3 times 1 plus 3. Negative 3 times 0 plus 1. Negative 3 times negative 3 is positive 9. Plus a negative 2 is 7. Negative 3 times negative 5 is 15. Plus a negative 4 makes 11. Now let's finish out that column. Let's get a 0 down there. So I can multiply the first row by a negative 2 and add it to the third row. The top row stays the same. The second row stays the same. And the bottom row becomes negative 2 times 1 plus 2. Negative 2 times 0 plus 2. Negative 2 times negative 3 is 6. Plus 1 is 7. And negative 2 times negative 5 is 10. Plus a negative 2 is 8. So my first column is done. Looking at the second column, the second row starts with a 1. So let's get a 0 below that leading 1. So I could do negative 2 times the second row added to the third row. First row stays the same. Second row stays the same. I'm changing the third row, which becomes negative 2 times 0 plus 0. Negative 2 times 1 plus 2. Negative 2 times 7 is negative 14. Plus 7 is negative 7. Negative 2 times 11 is negative 22. Plus 8 is negative 14. All right, we're done with that column. Now to the third column, the third row, this needs to be a 1 to be in row echelon form. So I'm going to multiply by a negative 1 over 7 to turn it into a 1. The top row stays the same. The second row stays the same. The bottom row becomes negative 1/7 times 0, negative 1/7 times 0, negative 1/7 times 7, negative 1/7 times negative 14. All right, so that is row echelon form. And that's where we stopped before. Now let's go backwards and put this in reduced row echelon form for Gauss-Jordan elimination. Which means we need to go up the columns now, and all the numbers above the leading ones need to be zeros. So we'll start in the third column and work way up and to the left. So I could do -7 times the bottom row, add it to the second row. Top row stays the same. That was a -5. The bottom row stays the same. The middle row becomes -7 times 0 plus 0, -7 times 0 plus 1, -7 times 1 plus 7, -7 times 2 is -14, plus 11 is -3. Make sure you watch your negatives, make sure you perfectly copy everything. Let's continue up the column. Let's turn that -3 into a 0. So I could do 3 times the bottom row, add it to the top row. Top row is changing. The middle row is staying the same. The bottom row is staying the same. Top row becomes 3 times 0 plus 1, 3 times 0 plus 0, 3 times 1 plus a -3, 3 times 2 is 6, plus a -5. And if it wasn't, that would be the next thing we'd turn into a 0 by adding the second and the first row. But it's already a 0, so we're done. So our equations are 1x equals 1, 1y equals -3, 1z equals 2. So in other words, that last column is the answers. 1, -3, 2. Let's try another. So let's start by making it into a matrix. It's 1x, 1y, 5z, and -3. -1x, -2i, -8z, and 5. -1x, 0y, -2z, and 1. The top left entry is already a 1, so let's start making zeros below it. So it looks like I can just add the top row to the second row. Top row will stay the same. Second row will stay the same. Second row is changing. Third row stays the same. Second row becomes 1 plus a -1, 1 plus a -2, 5 plus a -8, -3 plus 5. Now we need to get a 0 in the third row, so I could just add the first to the third. Top row stays the same. Second row stays the same. Third row becomes 1 plus a -1, 1 plus a 0, 5 plus a -2, -3 plus 1. All right. Let's get a 0 down there. Looks like I can just add the second and third. Top row stays the same. Second row stays the same. Third row becomes 0 plus 0, -1 plus 1, -3 plus 3, 2 plus -2. So we get a whole row of zeros. That means there are infinitely many solutions. That's right. So now we could stop, but let's go ahead and put this in reduced row echelon form. So the second row needs to have a positive leading 1, so I'll multiply it by a -1. Top row stays the same. Second row becomes positive, positive, negative. Bottom row stays the same. Then I want a 0 above the leading 1. So I'll multiply the second row by a -1 and add it to the top. Second row stays the same. Third row stays the same. Top row becomes -1 times 0 plus 1. -1 times 1 plus 1. -1 times 3 plus 5 is 2. Negative 1 times negative 2 plus a negative 3. So now we are in reduced row echelon form. We have two leading ones, and the column containing those leading ones are all zeros, except for the ones. All right, since it's many solutions, we're going to make the statement. Let z equal a. And then if I take the second row, that's 1y plus 3z is negative 2. But z is a, so y must be negative a minus 2. And if I take my top equation, which is 1x, 2z equals negative 1, but z is a, so x would be negative 2a minus 1. So our answer is x, y, z.